All right, so we have an exponential function here. F of x is equal to negative 2x minus 5. Um, name and write the equation of the apparent function. Well, the name of this is an exponential function, right? Because we can see that there is a variable in the exponent. The equation of the parent function is going to be, well, the base, and this takes a minute to get down, but if we look and we strip away all the other transformations going on, that 2 is the base of the exponential function. So this is y is equal to 2 to the x power. Now, in the last video we talked about this, but our key points are -1, 1 over a, 0, 1, and 1a. So if we think about this in terms of 2, again, we know the -1, 0, and 1 are going to be the x values. Now, how about the y values? Well, 2 to the -1, that takes the reciprocal, so we'll get 1/2. 2 to the 0 power is 1, and 2 to the first power is 2. Now it says list the transformations in correct order that have taken place in the parent function, or in the parent graph to result in the function f. We'll take these one at a time. Take a look. See, I'll give you a second. See if you can figure out what those would be. So the negative is where we're going to start, and the negative on the outside means there's going to be a vertical reflection over the x-axis. And then a -5 will shift the graph down 5. So this one, I know this is kind of crammed together, but this says what operations would you apply to the x's? We're not going to do anything to the x's. Both of these are vertical transformations. But we are going to take our y's and we're going to make them negative, and then we're going to subtract 5. So let's take our key points, which are -1, 1/2, 0, 1, and 1, 2. And let's say we're going to keep our x's the same, and then we're going to make our y's negative and subtract 5. So -1 is going to stay, 0 is going to stay, 1 is going to stay. -1/2 minus 5 would be -5.5. I'm just going to write -5.5. 1 made negative is -1. -1 minus 5 is -6. And then 2, -2 minus 5 gives us -7. We also want to find the equation of the asymptote, which horizontal asymptote is currently, remember in the last video we talked about this, it's usually at y equals 0, but when we shift that down 5 places, we are affecting the y values. So we're going to actually take our y equals 0, we're going to move that down 5 places. So we're going to see that we're going to actually have a horizontal asymptote at y equals -5. Let's plot these. -1, -1, 2, 3, 4, 5.5 will be here. 0, -6, 1, 2, 3, 4, 5, 6. 1, -7 is going to be down here. And we said we had a horizontal asymptote at y equals -5. Well, what that tells us is that this thing is going to come along here, and we reflected it vertically. It had a vertical reflection, so it's going to actually be going down that way. Okay, I think we have time to get this other one done. So this one is also an exponential. The parent function. The base is 1/4. So the parent function is y is equal to 1/4 of the x power. Thinking about our key points, again, our x's, -1, 0, and 1. If it's to the -1 power, 1/4 to the -1 power would flip that over and make it 4. 1/4 to the 0 power is 1. 1/4 to the first power is 1/4. So our key points are -1, 4, 0, 1, and 1, 1/4. Again, we got 4 here because we take 1/4 and we raise that to the -1 power. It flips it over. So, list the transformations in correct order that have taken place in the parent graph to result in the function. Let's take a look. What's that 3 out there doing? That 3 is a vertical stretch by a factor of 3. And then that -5 again moves the graph down 5. So, let's see what would happen. Our key points were -1, 4, 0, 1, and 1, 4. And we're going to not affect the x values, but we're going to take the y's, multiply them by 3, and subtract 5. Vertical stretch means we multiply by 3, and then -5. So -1, 0, and 1 are going to be our x values. And then 3 times 4 is 12. 12 minus 5 is 7. 1 times 3 is 3. 3 minus 5 is -2. 3 times 4 is 12. Whoa, this should be 1/4, sorry. It's a parent function right there. And, all right, I'm going to need a calculator for this one. 3 times 1/4 minus 5. So I get -4.25. Now again, our horizontal asymptote at y equals 0, but we're going to shift that down 5, so it would be down at -5. So -1, 7 is our first point. 0, -2 is our second. And 1, -1, 2, 3, 4.25. And we have that horizontal asymptote here at -5. So our graph, we can see that vertical stretch. This thing really stretched it out vertically. It would head that way.